In this lesson, we'll make the important distinction between qualitative and quantitative data. This would allow us to understand what kind of data and characteristics we're working with. So, let's begin by examining quantitative data. By definition, these are data that can be measured in a numerical form. The values we use to depict the data are estimated in the form of numbers or counts. Each data set is associated with a unique numerical value. In general, quantitative data is used to describe numeric variables. Digging a bit deeper, we can say that there are two basic types of quantitative data. These are discrete and continuous. Now, discrete data can only take certain values or counts. Think of integers that can be both positive and negative. Okay. In practice, sales volume is a discrete type of quantitative data, measuring the amount that was sold in units. How about estimating website traffic? Indeed, the number of visitors or sessions is also classified as discrete quantitative data. Here, we measure whole numbers. Alright. Continuous quantitative data, on the other hand, can take any value. Essentially, we are not only dealing with integers, but with any type of real number. For example, a company would want to measure the return on investment of a project, or a stock price. All these are categorized as continuous data. Of course, the figures we use to do that are not necessarily integers. ROI can be 15%, and a stock price on a given day can be $7.15. Here, we also consider continuous numbers that are not whole figures. Alright, great! Another way to classify quantitative data is to differentiate between interval and ratio data. Interval, also known as scale, data refers to data that are measured along a scale. In this way, each point on that scale is placed at an equal distance from one another. With interval data, differences between measurements matter. However, there is no absolute zero. Think of the year a company was founded. It grows from 1 to 10, 20, or more at regular intervals. Or your GMAT score, which falls in the range from 200 to 800. In both cases, we don't have an absolute zero. Makes sense, doesn't it? Okay. Moreover, we can have ratio data. They are measured along a scale with an equal ratio between each measurement and an absolute zero. Here, the absolute zero is treated as the point of origin. Logically, there can be no negative numerical value in ratio data. Can you think of some examples? This can be the total revenue a company generates. It is possible to have zero sales, right? Yet, a negative revenue figure is not an option. How about the conversion rate of direct marketing campaigns? Again, if no one converts, your conversion rate will be zero. Okay, very well. These are the different ways in which we can describe quantitative data. Let's continue with qualitative data. They can be described as information collected in a non-numerical form. Qualitative data are descriptive in nature and involve text or categories, but also integers when recorded. Common examples include gender, test results, even degrees of customer satisfaction, which can be denoted as not satisfied, slightly satisfied, satisfied, very satisfied, or extremely satisfied. But how can you possibly measure this? Quite often, researchers try to record qualitative data with numbers to quantify their meaning. As such, they can be categorized into two types: nominal and ordinal. When we say nominal data, we mean data that don't have a natural order or ranking. They just cannot be measured. Even when coded with numbers, the order is arbitrary and calculations with these data are meaningless. Consider someone's marital status as a case in point. If 1 stands for married and 2 signifies single, 1 and 2 cannot be interpreted meaningfully. You don't know what's the result of 1 plus 2 in this particular case, right? Okay. Ordinal data, on the other hand, have ordered categories. Nevertheless, the distances between different bands on the scale are not known. What you need to remember is that with ordinal data, order matters but not the difference between values. In a questionnaire, we can have respondents mark their socioeconomic class as poor, working class, lower middle class, upper middle class, upper class, but that doesn't give us information what the income difference between each class is. Alright. Finally, we'll distinguish between qualitative data and binary categories, which are called dichotomous. Okay. Dichotomous data can only take two values, typically 0 or 1. For example, you're either under the age of 30 or above. There's nothing in between. The same goes for loan repayment. You either default on your loan or you don't. Actually, nominal or ordinal data with more than two categories can always be converted into dichotomous data. Instead of X possible data values, you get X dichotomous data with a value of 0 or 1 each. And that's really useful when you want to quantify the findings of your research. Let's take a closer look at the socioeconomic class example we've just discussed. Here I'll add 5 columns to the database, each of them labeled poor, working class, lower middle class, upper middle class, upper class. Okay, for each row or each respondent, only one of the columns will contain the value of 1. While the rest will be shown as 0. In this way, 1 will designate the answer a respondent marked, and the rest of the columns will contain a 0. Well done! We've just covered the basic data types. Here is a useful summary for you to remember. Feel free to reach out to us if you have any questions.